Okay, on 7 and 8 here, I don't have the exact same graph that you guys do, but the concepts still end up being the same. So I'll give my solutions according to what the graph I have here is, and on yours, take the same concepts, same ideas, and use them to answer it on your own. The first question on these is asking if it's increasing, decreasing, or constant. Well, this graph is definitely not constant because it's not just going horizontal. That's what constant means on your graph. This one, since the graph is going down as you go from left to right, it is going to be decreasing. And then B is asking if the graph has an increasing, decreasing, or constant rate of change. The rate of change is the slope. So look up here at the slope. It's pretty horizontal. So that's a slope close to 0. But if you look over here, the slope's like this, which is a negative slope, something like, like -3 or -2. And so if you're going from 0 to -3, that would be a decrease in your slope. And so the rate of change is decreasing here. And then you got this positive interval, negative interval. You write down in interval notation where the graph is positive, as in above the x-axis up here, and where it's below, that's the negative portion, okay? So it changes right here at x equals 2, and so my positive interval, it goes from negative infinity up to 2. Because all the way here, as you go left forever and ever, it's still going to be positive. And as you move to the right, it goes positive until you reach 2. And so that's why it goes from negative infinity to 2. And my negative interval goes from 2 onward. Because as you go to the right from 2, it's going to be down below the x-axis. And so that's going to be my interval there. The end behavior is asking what happens to the y values as you go to the far left and as you go to the far right. So you hop on your graph, head left forever and ever and ever, and this one actually looks like it goes level there at this y value, which is 1, 2, 3, 4, 5. And so I would write as x goes to negative infinity, y goes to 5, because that's the y value over here when it goes horizontal, practically. And as I move right, so as x goes to positive infinity, so as I go right, what happens to the graph? It goes down, and it continues to go down forever and ever, and so my y is going to go to negative infinity. And now I need to calculate the average rate of change between the 2 points marked on the graph. That's this point and this point. If you want to count things out, this would have a, this would have a rise of down 4, so that's -4, and a run of 2, so that's going to be a rate of change of -4 over 2, or if you simplify it, just gives you -2. So that's going to be 7. When you get over to 8, a little bit of a different graph. Again, this one, as you move from left to right, this graph is going down. And so this graph is decreasing. So if it was going up like this, that would be an increasing graph. Or if it was just horizontal, like so, that would be a constant graph. Okay, but it's going down as we go left to right. The slope itself over here, look at the left side and progresses from left to right. What happens to the slope? Over here, my slope is negative, something like, I don't know, maybe -2. But as I get over here, my slope is pretty shallow, really close to 0. So if you're going from something like -2 to 0, that would be an increase. And so my rate of change is increasing. The positive interval, negative interval, again, these are just where the graph is above the x-axis, where is it below. And it actually changes right there at that point, which is x equals -2. And so from the left side, from negative infinity all the way up to -2, this graph is above the x-axis, so that's why the interval is going to be negative infinity, negative 2. And then after that is below the x-axis, so it goes from negative 2 to infinity down below, and that's why the negative interval is there. The end behavior is you hop on your graph, head left for forever, because that's where x is negative infinity. Well, the graph goes up and up and up indefinitely, and so the y value is going to be positive infinity. Now we need to head right, go to positive infinity in the x direction, so head right on your graph here, and it actually hits this asymptote here, or gets closer to that asymptote there, which is a y value of negative 3. And that's why it's there. We need to now calculate the slope between these 2 points. The rise here looks like negative 2, and then I'm going to run 3. 1, 2, 3, yep. And so I have a slope of negative 2 over 3. Remember, change in y over x, or the rise over the run. And there's your 7 and 8.